All right, so in this video, we're going to go over a couple examples of how to multiply radicals, okay? So in general, right, when we simplify, let's think about the way that we simplify a radical. Say we started with the square root of 12, okay? Well, what we would do is we would break that down into the product of square root of 4 times the square root of 3. So we're used to breaking it down into two radicals. Well, now what I want to teach you to do is when we're asked to take the square root of 4 times the square root of 3, we need to understand that not only can we split the two radicals, but we can also, in a sense, put the radical back together. We can multiply the 4 times 3, and we can go backwards and get square root of 12. Okay? So when we multiply with radicals, we don't need to have like radicals. As long as both numbers are under the radical, I multiply both those numbers and that number stays under the radical. Okay, so let's just start with a pretty simple example right here. And let's suppose that we need to take the square root of 6 times the square root of 3. Okay, well, I would always look to first and see if these two radicals can simplify, and they can't. So what we're allowed to do is we can then condense this into a single radical, and we can say that this is equal to the square root of 6 times 3, which is the square root of 18. Okay, and then what we need to do is split that. We need to simplify. Okay, so now we need to simplify this because a lot of times when we multiply, we make the numbers bigger, and we have to then simplify to break it down. So what perfect square goes into 18? Well, we could split this into the square root of 9 times the square root of 2. Because remember that since 3 squared is 9, then we can take the square root of 9 and go backwards and get 3. And so we can say that the square root of 9 is 3, and then we're left over with this radical 2. Okay? So if this part is equal to 3, sorry about that. So let's say this is 3, then what we could do is we can say this is a whole number 3 with a square root of 2 left over. And that would be the final product. Okay? So let's do something like this. Let's suppose we take 3 square root of 15 times 4 square root of 6. All right? Well, what we can do is we can multiply the two whole numbers, and we can take 3 times 4 and get 12. And then we can multiply the two radicals together and condense it into a single radical and say that it is the square root of 15 times 6. Well, when we do this, we get 12, and this is going to be the square root of 15 times 6, which is 90. So this looks great so far. So all we need to now do is we have 12 square root of 90. So we're going to simplify the square root of 90. All right, so what we can do is we can split this into square root of 9 and square root of 10, and then we multiply out in front the 12 and just bring this down. All right, so which one is the perfect square? The perfect square is the square root of 9, which is equal to 3, and then we times that by the square root of 10. So when we condense all of this together, 12 times 3 makes 36, and we're left over with the square root of 10. All right? So let's work through maybe a distributing type problem, okay? So let's say here in example 3 that we do something like take 2 square root of 5 and times that by square root of 6 plus 2, okay? I think one thing that might help with this is maybe we put a 1 in front of this. So when I distribute, I take 2 square root of 5 times 2 square root of 6. I multiply the 2 and the 1 together to get 2, and the square root of 5 times the square root of 6 can multiply to make square root of 30. Okay? And then what we're going to do is we're going to take 2 square root of 5 times 2. So 2 square root of 5 times 2 means that we can multiply the two whole numbers together, and the result is going to be 4 square root of 5. Now, since these two radicals are not the same, and neither of them can be simplified, this would be the final result, and we would not be able to add anymore. All right? So it doesn't always have to be a lot of steps when you're multiplying. All right, last problem. Let's suppose that we have 3 minus the square root of 5 squared. Okay? Well, the first thing to remind you when you have a quantity that's squared is what that means is you write it twice. It means that you have double that quantity. Okay? And so now this is going to be a FOIL where we multiply the first terms, the outer, the inner, and the last. And so 3 times 3 is going to give us 9. And then we take 3 times negative square root of 5, and it's going to produce minus 3 square root of 5. Okay? When we take a 3 times the square root of 5, all we're doing is kind of, in a sense, condensing that whole number in that radical. Now, let's multiply the square root of 5. And we're going to get, again, negative 5 times 3 is the same thing. It's negative 3 square root of 5. Finally, here, we take negative square root of 5 times negative square root of 5. Well, the first thing I notice is that a negative times a negative is going to make a positive. And the square root of 5 times the square root of 5 is equal to the square root of 25. All right, we have a little bit of simplifying to do. First thing I want you to notice is, do we have a perfect square? And you might notice here that 25 is a perfect square. So we could then say that the square root of 25 is equal to 5. So let's simplify this. Let's turn this square root of 25 into the whole number 5. All right, so what do we got so far? We've got 9 minus 3 square root of 5 minus 3 square root of 5, and then the square root of 25 becomes a 5. All right, I have a couple different things I can do to combine like terms. Well, one thing I noticed is we have a 9 and a 5, which can combine to make 14. But I also noticed that a negative 3 square root of 5 and another negative 3 square root of 5 is going to combine to make negative 6 square root of 5. So remember, when you add and subtract, you do need to have the same radical, and then we just combine the two coefficients, and that's where we got the negative 6. All right, so that's just a few examples that we did in class just to get you started on how to multiply radicals. All right, I hope this helps. We'll see you in class. Bye.